Picture this. You and your 4 classmates have been given an odd assignment. March in a circle. This doesn't sound terribly difficult until the teacher tells you that you will have to do it on a floor made entirely of conveyor belts that aren't all facing the same direction. You won't be able to study the floor beforehand, and to make matters worse, during the actual assignment there will be a low fog covering the ground. How are you supposed to do this? Fortunately, 2 scientists from the University of Maryland, Dr. Cameron Peterson and Professor Derek Paley, have solved this problem. Sort of. They were interested in getting robots to take measurements in the ocean, so their original solution works for swimming robots, not walking people. Why does this matter? Because robots can do complex math in a matter of milliseconds, and most humans can't beat that even with a calculator. Since the scientist's solution does involve some math, they convince your teacher to make the problem slightly easier. Instead of having the conveyor belts running the entire time, they will be on for 1 second every minute. Everyone will take one and only one step right before they move. Now Peterson and Paley's method will work for you, and they agree to teach it. You show up on the big day with a map of the floor to fill in, a calculator, and the mental checklist the scientist taught you to do every time the floor moves. You also have 2 partners, which you chose by circling up and saying, "You on my left and you on my right are my buddies." Let's say that your buddies are Susie and Billy. You've got everything you need, so it's time to get started. The floor is arranged as a square grid with numbers and letters on the wall so you can tell where you are. You know that these parts of the grid count as a circle. The goal is to be in one of these squares at the end of every round. You all spread out on the floor, take a step at random, and the floor moves. Now it's time to apply Peterson and Paley's checklist. Step 1. Get numbers. You remember you started in D4 and tried to step here, so E5 is where you think you were when the floor started moving. That means the conveyor belt at E5 took you here, up and to the right 1 grid point. So you write the numbers 1, 1 and E5 on your map, and you're done with step 1. Step 2, the consensus filter. In this step you ask Susie and Billy if they've been to E5 before, but since that was the first round, they haven't yet, so you move on. Step 3 is called the information filter, but it doesn't apply yet either since that was your first time at E5. Finally, step 4, plan your next move. If you had more information about the floor, you could plan based on that. Since you don't, you decide to try to follow the circle by going to F3. You take a step, and the floor moves. Now you repeat the process. Step 1, get numbers. You think you moved here, so the floor moved you here, down and left 1 grid point, so you write -1, -1 in F3. Step 2, the consensus filter. Once again, you ask your buddies if they've been to F3 before, and once again, they haven't. Likewise, step 3 is pointless since that was your first time there. You went with step 4. You decide to try stepping to F3 again, just to double check it, so you move, and so does the floor. Now you're back at step 1. You moved here, so the floor moved you nowhere? But you've been here before, and if your previous numbers were correct, you should have ended up right back where you started. Well, step 1 is just to get numbers, so you write down 0, 0 in the square. Then in step 2, you beg your friends if they've been there before so they can help you sort this out, but they haven't yet. Now it's finally time to use step 3, the information filter. The information filter is a way of getting rid of uncertain answers in favor of more confident ones. It works by looking at all the previous numbers recorded there and taking a weighted average. Weighted just means that if you were really confident that, say, 0, 0 was right, the final answer would be closer to it than to -1, -1. This time, since you are equally unsure of both answers, you just take the halfway point as your new answer. -1/2, -1/2. Finally, for step 4, you decide to follow the circle. Everyone steps as the floor moves. Time to run through the checklist again. You think you stepped here before the floor moved you here, so you write that you moved up 1 and right 1 at E2. You move on to step 2, but before you can ask your partners for information, Susie pipes up and says, "Hey, have you been to F3 before?" "F3? Of course I have. These are the numbers I got." "Really? 'Cause I got these." This is where the consensus filter comes into play. You both have different values for the same spot. The goal here is to arrive at identical, and ideally correct, values. To do this, you once again take a weighted average. You, having been to F3 twice, would have had a more weighty answer if you had measured the same thing both times. Since you didn't, you both move your answers halfway to get a common answer, and you write this down at F3. Notice that now, if Susie's other partner asks her for information about F3 down the road, she will be sharing your information as well as hers. In this way, the consensus filter not only helps 2 people converge to the right answer, it indirectly helps everyone get to the same right answer without having to communicate with everyone all the time. You're still not done with step 2 since you still want information on E2. Turns out Susie has been there as well, so you once again compare answers. Yours say you went up 1, right 1, hers say she went 2 to the right. You split the difference again, and these are your new numbers. That was your first time there, so you skip step 3. Now you do step 4. You would try to go directly back to the circle, but you're pretty sure now that that part of the floor will just push you away again. So you try going around, everyone steps, and the floor moves once again. And that's the basic process. Using this checklist, everyone measures the floor, shares answers, trims uncertainty, and decides which way to move. Eventually, everyone has figured out enough about the floor so that, at the end of every round, everyone is somewhere on the circle. After doing this perfectly for one whole revolution, the teacher says, "Good job," and that you're finished. You're finished with the assignment, but you still have one more question. Why was this problem so important to the scientists? Why make robots swim circles in the ocean? Because a lot of people want to know what the ocean is doing. Marine biologists, climatologists, and the military are all very interested in knowing what the state of the ocean is right now and how it's changing. To figure this out, scientists measure the ocean's temperature, how salty it is, and which way the currents are going. But the ocean isn't the atmosphere. You can't just see through it. This means that anyone wanting to measure the ocean has to send probes to the exact spot they want to measure, which runs into the second problem with measuring the ocean. It's huge. There is no way to measure all of it practically, so you need to find the most important spots and measure there. How will we do that? By building robots that can figure out where these spots are and then guide themselves based on continually updated information. Which brings us back to the circle problem. Dr. Peterson and Professor Paley wrote their solution to help with the guiding problem, how to get several unmanned robots to act as a team while swimming through a changing ocean. The circle formation was just a start. The end goal is a team of robots capable of giving us truly accurate ocean information. Special thanks goes to the National Science Foundation for funding my research this summer at the University of Maryland. Also thanks to the people who helped me understand the paper behind this video: Professor Derek Paley, one of the authors and my advisor this summer, Frank Lagore, my supervisor here, and Dr. Don Petcher of Covenant College, my advisor during the school year. Finally, if you liked this video, please check out CGP Grey on YouTube or iTunes. His video on how to become the Pope taught me that animated stick figures can be used successfully to educate and entertain at the same time. Thank you so much for watching. Have a good day.